G'day guys, this is just a quick video on a question that arose in the supplemental video on the Novavax. I'll just share the screen and then we'll get on with it. Okay, so Scott W. actually said, on the lipid nanoparticle causing issues, it might depend on where they end up accumulating. That's true. And also he's got a video link here, talks about the Freedom of Information request result to the Japanese government, shows where they end up with the Pfizer vaccine. It's one thing that we've been talking about the Pfizer vaccine being problematic, these mRNA. The other type is the viral vector type. They also insert themselves through into the actual cells and stuff like that to use replication systems and stuff like that. We've got issues with these, and we've said it from the beginning, me and Bart and a number of others, that there are problems with this sort of technology. We've seen autoimmunity, also all sorts of things in past stuff. And I actually mentioned some of this sort of stuff like viruses, reactivation, and all sorts of other things. I'll explain what my thinking behind this is, but I've actually thanked him for the information because I wasn't aware of this actual website and the people that are involved. I knew the actual one of the guys who was involved in the development of the mRNA vaccine, but I didn't know the other two characters. So let's get on with it. I'll just turn it quickly here. So that's the channel, Dark Horse Podcast Clips. And this is Pfizer reveals where the nanoparticle collects. That's Robert Maloney, that guy there. I think that was that guy there, Steve, and Brett. I think it's this guy over here. So let's get on with it. I'm just going to cover a few of the points that they make, which is really important. So remember the last video I showed the reactivation of the herpes virus and, the shingles, that sort of, and the herpes virus and a few of the other sort of related stuff. So let me just make sure, just give me a sec. I think I don't have the audio shared. So I'll just stop that for a sec and I'll share again. Do apologize with audio. Okay. Let's try this again.
Is reactivation of latent viruses.
Mm-hmm.
Okay, so this
Herpes
is
zoster.
shingles. Shingles is an example of that, but there are many others, and there's something in the literature about reactivation of latent human retroviruses.
So they're talking about retroviruses. They're talking about things like shingles, things like herpes, and all that. Now, some of these viruses are actually suppressed with calcium in the soft tissue. They don't talk about that, but that's what happens. So there are certain biological processes that are important in terms of calcium regulation, vitamin D being one, MK4 being the other. So I've covered that before. You guys are quite cluey about that and up to date, so I don't need to cover it here in that regard. But this is important, what they're actually saying. Now, I'm going to cover a few of the other things. I'll go into the autoimmunity part. I'll actually provide a link and people can go back and look at the whole thing.
Yep. Which we didn't expect in the literature. And we were, the developers assured us this would not happen. The literature suggested we would not have free spike.
Yep.
And then Harvard and Brigham.
See, the actual developers, Pfizer, said, we're not going to have any free spikes in there. Remember the Novavax actually has 2 prolines on the receptor. So basically can't react. That's an important thing. I'm going to cover all this sort of stuff because it's very important. It's one thing being in the bloodstream and another thing getting into the cells and all that. This is the problem with the Pfizer thing. And the difference is, now, I'll cover that little portion.
We did a study in nurses, and lo and behold, we clearly have free spike after vaccination.
Yeah.
And
why do we have free spike? Well, obviously because it's an mRNA. It can replicate, so it can get in take control of the replication systems and replicate out of control. It's probably worse in current populations. Why? Simple. What's the issue in current populations? Vitamin D deficiencies. Vitamin D deficiency means you don't have a well-modulated and regulated immune system. Another issue, a confounding component, which is not being looked at this current stage. So we don't know how much that is playing a role in terms of, the way the virus is actually functioning, modulation, stuff like that.
That has a whole other set of implications, but development of autoimmune disease against complexes of foreign protein plus normal human proteins is certainly something that you'd have to monitor for.
Yep.
As
I said, Rob Maloney, I was aware of it. I don't really know this guy here, Brett. So I've got these people wrong way around. So this guy's an evolutionary biologist. Evolutionary biologists are basically that look between species, how they evolved and stuff like that, and what are similar genetic components. So this guy is the guy that actually has the information. Okay. So this guy is vaccine developer. He's a virologist. He actually is in this specialized area. He knows his shit, so to speak, because he's actually the inventor of this technology. Yes.
We're discussing the way that's part of the reason why you typically want a 2 to 3 year follow-up period on the initial group of phase 3 patients to make sure that autoimmune consequences don't develop, because they typically...
See, this is the other thing. We need to know, he's actually saying quite clearly about, having a few years, because basically we're just rushing this stuff. This is not how traditional vaccines are developed. They'll mention it further along.
Typically take time.
Right.
And this is why, they always say that there's no such thing as a vaccine that is developed fast. Like the fastest we've ever developed a vaccine has been like 7 years or...
Yeah, probably unless we go back mid-century when things were...
See, 7 years. So you actually take it, you develop it, you test it. You don't rush things. These take time to develop and be tested thoroughly before unleashing experiments on the general population. We've overreacted to a respiratory infection that basically is just slightly worse than the flu that could have been mitigated with vitamin D and other strategies, ivermectin and stuff like that. We do not need to basically be experimenting on the whole population with stuff which is very problematic, to say the least. It's what I've been saying from the beginning. Bart's been saying it, and many others. Some of the stuff, and we've been very clear about this, some of the stuff we can see these sort of relationships and potential risks, and that's what we're talking about. We're talking about potential risks because we have to be serious. I mean, we haven't done the research to know, but we're seeing certain issues emerging. We're seeing reactivation of viruses. How does that happen? Simple. I see it as basically, I know that we know quite clear in the literature, this is not Harry saying it, that viruses exchange information between themselves. So if you're putting a replication system in there, and it's getting through into those into those areas where you've got things that have been suppressed slightly by the immune system, and you're circumventing slightly some of these things, and you're putting in machinery that can provide, replication machinery and can actually exchange and all that. Potentially these viruses are actually taking control of this components, this man-made component, and using it for their own nefarious things to, all organisms are trying to survive, all organisms trying to replicate, okay? It's all about evolutionary, trying to outdo the other. So it's competition between different organisms. So it does not surprise me. It surprises me that basically people are rushing for the big dollars in terms of getting stuff to market, and are not basically, and governments are more concerned about the economic implications rather than the health implications. So it's quite appalling. and assessing these things properly with independent organizations and boards of specialists, not industry players. The problem is the government's around has all these industry players which are pushing an agenda, and they don't give a shit about you, I can tell you.
We're loose and fast.
Right, but there's a reason for that. It's not just that, okay, well, we didn't have the technology, we have better technology now. We still need to be able to see what the long-term effects is on a 12-year-old.
Time. And in fact, usually you use animal models to do that, and the assumption.
So, pretty much what we're talking about here is we can't go ahead.
Give us is a signal that alerts us to things that we need to follow up on carefully in humans.
Yeah. So what he's talking about is the animal models are used, and that's why they do them over a long period of time, a number of years. They're doing animal models to see, because I'll give you an example, rats. Even though dietary-wise, animal models are not very useful because all animals have different dietary sort of adaptations. So that's why the dietary stuff is shit in most cases. But when it comes to basically physiology, all mammals will react to certain things in a certain way. Viruses, bacteria, and all that will operate in a very similar way. And so we can actually work out if it's causing autoimmunity, certain reactions in rats, it's going to cause that in other mammals, including ourselves. And that's where these studies, but we haven't done enough of these. We haven't done long-term. Remember, a rat actually lives for about 2 years. So really you should have a rat on a 2-year study to see exactly what's happening, because their metabolic rate is much higher than ours. And so they actually undertake cell division much more rapidly than us. And so eventually die earlier than us, about 2, maybe 2.5 to 3 years, if best, if you're a super rat. But that gives us an insight on whether certain things are good or problematic and all that. And that's why it takes about 7 years with a lot of animal studies and then human trials and stuff like that with volunteers, because we need to know before we start experimenting on millions of people in the population. So what we're currently doing now, because we are driven by profits and politics and not by science, which is very bloody important. Now, let me go back to the delivery box, which they talk about. And this is very important because it'll all come together, and why we don't need to worry ourselves about when we're talking about the Novavax, but we do need to worry about things like Pfizer and Moderna and stuff like that. Why there's a difference. Okay.
It's the FedEx delivery box that has the mRNA inside.
This is, you're exactly.
It's the FedEx box that has the mRNA inside it. This is the lipid nanoparticle.
Right. This is the lipid component.
Yeah.
That does the delivery.
Okay, so good. So what we've got here are different lines that tell you over time from a quarter of an hour to 40.
Now, this is important. Lipids, like phospholipids and stuff like that, they go in all tissues. Okay, so we need to be clear about that. That is normal. I mean, if you actually get phospholipids from an egg, you eat an egg. That's got phospholipids in particularly the yolk's very high in phospholipids. That'll go to the brain, to all sorts of tissues. That's a good thing because it's delivering all sorts of very important fat nutrients and stuff like that. Don't get me wrong. This, on the other hand, is basically bringing in a Trojan horse into all sorts of tissue. It does not surprise me because it's inside one of these, and these lipid nanoparticles with their Trojan horse inside can go into all sorts of tissues, ovaries, brain, all sorts of tissues. Okay, the lymph nodes, the lymphatic system, everywhere. Because remember, usually fats, like even chylomicrons and whatever else, they are basically, what are they? They are basically just larger versions of something similar, which is basically bilayers, lipid fatty, which is, these bilayers of fat and stuff like that and proteins, and they will go anywhere. So just keep that in mind. And that's the normal thing. They're using it. They've got the stuff inside. Now, normally these nanoparticles of lipids will basically will be, any of the lipid proteins that we're well aware of, and they can move in and out of all sorts of tissue. Got it? This is important, the difference that I'm pointing out. And then they've got this sort of stuff, which is man-made, which can react with all sorts of stuff in all sorts of tissue. So it gets in. Now, how does it do that? Very important. Let me go down to here.
And he has some theories having to do with charge associated, because these are charged lipids. So
Did you hear that? These are charged lipids. Remember I was telling you before how ionic, like zinc, has got a positive ionic charge. And the only way to get it through, because you need sort of that negative charge to go through a certain receptor, you need to piggyback on an ionophore. That means something with ionic charge that is able to get through that cell membrane, because zinc can't do it. So it has to attach itself to an ionophore like quercetin or whatever. Attaching to it, it can go straight into the cell. By going straight into the cell, it can basically inhibit replication, which in the respiratory area, like with chewable, with an ionophore, we can get into those respiratory in the early stages of a disease to stop replication and retard it, to give the immune system enough time to fight back. With a good vitamin D status, you can do that. I've explained that in my earlier videos when it came to COVID and some stuff like that as what you can do. You guys are well aware of it. You're cluey, you're up to date on that sort of stuff. These guys are explaining exactly that what these Pfizer researchers have done is they've put this ionic charge on there so they can actually get their Trojan horse, their mRNA Trojan horse, into all these cell areas, into all this tissue. Got it? That's what's happening.
Just says what?
Yeah, that is a very frightening signal.
And it's the cognitive dissonance between what the CDC says is that this is safe for pregnant women.
Right.
And it's getting into the ovaries like mad. It doesn't surprise me, because when you've actually got it in a lipid thing, it can go into all sorts of and if it's got the right charge, then it can enter every single cell of the body. Okay? And it's got replication, so it can replicate itself. Most people don't have very good vitamin D status to control that misbehavior. And it's going in there and exchanging some of its cargo and interacting with potential other viruses which are suppressed by calcium, and giving them a new lease of life, so to speak. And that's why on the last video that I actually talked about, the supplemental, I actually discussed about some of these reactivation and stuff like that. These guys are talking about the same stuff. And also they're talking about tissue concentrations. This is what happens when you don't use traditional traditional techniques. The traditional technique is to create deactivated forms of the actual proteins, stick them in the body, the immune system attacks them, knocks them off completely, and they don't go around replicating like mad. They are taken out in that early stage. The immune system gets the message. This is what you need to target. It's a foreign thing. And this, on the other hand, replicates and spreads. And the reason why it spreads, why does it spread? Simple. It's in a lipid. That's the important thing. It can spread into all sorts of tissue around because it's a lipid. It goes through the lymphatic system. It spreads throughout the whole body. That's what's happening because it's inside. Now, what's the difference of Novavax? It's not inside the lipid. It uses even a smaller lipid, just a lipid, which is the size of 25 nanometers. And they stick the spikes on the outside. They use the lipid to let's say, how can you put it? It's like basically having a piece of wood and then sticking the nails on it with glue. So basically that lipid nanoparticle right in the center sticks all these nails. Got it? So the moment it enters the body, the Novavax, it enters you inject it in that area. One, it doesn't have replication capability. So whatever you inject can't replicate any further. That's it. Whatever goes in, it goes in, no more, which is important. These things are in cargo, which means they can move through the lymphatic system and all sorts of places. That stays there, gets attacked by the immune system as foreign proteins, gets taken out. It also can't get into cells because it has the two prolines which are attached to it, preventing the spike from reacting with any cells or receptors. No go, it's stuck. Where it gets in, it's stuck. It's not in a lipid to move around through the lymphatic system. So basically, it's just like injecting any foreign protein. Your body will just jump on it and take it out completely, which is no different than a virus or a bacteria or whatever. If it gets through, the body will just jump on it and get rid of it. Okay? So it will not spread throughout the whole body. This uses a lymphatic system. It goes through the lymphatic system because that's what chylomicrons do. All these things use, fats, and that's why it's getting around. And these are very small, very easy to get through the lymphatic system and spread throughout the whole body. And that's what's probably happening. I'm speculating here, but I wouldn't be surprised. This is what the data shows quite clearly, that these are concentrating in certain organisms. Eventually, they go through the lymphatic system, and certain organisms in certain cell types in the body, they seem to be able to replicate much better than others. Why the ovaries and not in some other areas? Well, if you think about it, what's the ovaries? The whole ovaries are designed to actually grow things, to produce things and all that. So the machinery in there that's being hijacked is able to increase the replication probably to manyfold, where in other tissue, it's less capable of doing that. Bone marrow, again, it actually is producing stem cells and all sorts of things. So it's got machinery that can build. That is why in those two tissues, you're seeing this greater elevation, where all the others, as you can see, with all the others are sort of dropping off. This is speculation on my part, but I suspect this is the reason, because these tissues have the ability, like stem cell type abilities and stuff like that, to produce things more. These other tissues don't. And so it drops off eventually. So this is the reason for that. Problem for women? Now, as far as male reproductive systems, we don't know because we haven't seen any studies yet. So I can't comment on that. But I wouldn't be surprised if something's happening there as well. And I'd be quite worried if I was a male and I'd taken the Pfizer jab, or the Moderna, because they use the same technology. This is the difference. This stuff is inside the nano. It's not a small little globule in the center without any stuff in it that can be problematic. And you've basically just got the spikes stuck to it, which means that the immune system can react immediately to that foreign protein. It's not encapsulated. By encapsulating in a lipid protein, what they've done is they are hiding the actual delivery vehicle. See, the whole reason is they want to hide this protein, this mRNA, foreign protein. They want to hide it from the immune system so it can actually get into cells to replicate. That's a problem. We don't want that sort of shit happening, because that's not what traditional vaccines are. Traditional vaccines are to basically deliver a localized dose with the proteins there visible to the immune system, and the immune system just jumps on them and takes them out. It says, this is foreign. It shouldn't be in my body. It needs to be taken out. And all they're doing is, because they're using a small, raft, a small 25 nanometer lipid protein, nanoparticle, that's small, nothing in it, that's problematic, and they put the spike, and they've stuck the spike glued in a sense. It's like gluing, and that's a raft that rafts these spikes on it. They're visible to the immune system. They're not hidden. They're not inside. They're on the outside, visible, pointing out, with no ability, because the proline proteins, no ability to, get into any of the cells or use the receptors. So basically, it's in the blood. It's at the localized level. At most, a few can get into the bloodstream, but they can't replicate. They can't increase, and eventually, the immune system, within a small amount of time, will get rid of them. So, the immune system is quite brutal in getting rid of foreign proteins. And that's the good thing about the immune system. But that's also the problem with the immune system. Things that are inside, bilayers of lipids, they can't see them. It's like the LDL. It's got a whole lot of stuff inside, but the immune system can't see it. But luckily, the LDL is just carrying triglycerides and things, which vitamins and minerals and stuff like that. It's not something that's actually going to harm you. It's carrying things that are nutrients to the body. So it's not a problem. And we don't want the immune system reacting to that sort of stuff. But when you actually put an mRNA foreign protein inside such a thing, and the immune system can't see it, and it's just a bilayer of lipid, which it just recognizes as just another bilayer of fat, that's okay. We know fats and stuff like that move through the body. So through the lymphatic system, the body just, and that's where the problem lies, that this is spreading through the lymphatic system, I suspect, all over the body. And that's the problem. So pretty much it's starting to confirm some of our fears, and our speculations may be true or problematic. We don't have long-term studies. We don't have 3-year studies, and we don't have long-term 7-year developmental and, extensive animal studies. Then they usually go from like rats and stuff like that to primates, which are closest relatives, to see what happens in them as well. And that's why it takes up to 7 years. So to know exactly what it's causing. They've accelerated this stuff. And as I said, if you don't need to take the jab, just keep your vitamin D status high. If you can get access to ivermectin, fantastic. If you can't, just keep your vitamin D status high and you'll be fine. If you can get injectable vitamin D, so you can actually get quick, because it's basically in 25-OHD, so you don't have to convert it in the liver, even better. If you can get access to that, keep it in the fridge for the moment you may need it. And I've given you the video in the previous one, so you can go and actually look how it's actually done, how to administer it yourself. So that's the situation. I would not be touching these, viral vector or mRNA type methods. Very problematic. And even the Novavax, while I don't think it's a problem, because it basically, the spikes are visible as foreign particles. They are very much like traditional vaccines, like the flu vax, where you release all these proteins in that localized area. They can't replicate or anything like that. And they're attacked by the immune system, and the immune system gets a certain, an innate sort of memory of, what it needs to look at in the future. These other things are circumventing these natural defense systems, getting into all sorts of areas where they shouldn't be, and replicating. And reacting with all sorts of tissue. This is the problem that we predicted and talked about. And some of this stuff, luckily, the Japanese are starting to do some really good research and investigation in this, and are starting to reveal some of this information. But unfortunately, it's, I wouldn't say too late for people. Now, if you've taken one of these things, as I've said, maintain a good vitamin D status. That's your only option at this stage. You need to maintain a good immune system so you can actually deal with this. I've got no other solution for you. We told you, don't take those options which are experimental. So I'll leave it at that. I just thanks Scott. I think he may, as he said, I don't know, he talks about here about the lipid nanoparticles causing issues. Might depend on the end accumulation. And as I said, it depends on how it's actually packaged. Very important. It's the packaging, you know, is it inside or is it just a raft that other things stick and immediately it's removed out of the system? You know, it's attacked at that point and it's engulfed by the immune system and destroyed and ripped apart, and it goes nowhere to cause any problems. It's a localized thing. And that's what traditional vaccines do. It's a localized thing. These other stuff going potentially through the lymphatic system, which is definitely not a localized thing. And they've got replication capabilities in all sorts of tissues. And in particular tissues, which tend to basically have type, you know, like the stem cell type or the growth. I'm not going to speculate. We've got no fucking idea what they're doing in these tissues, really. And that's what worries me, because we do not have enough research into what is happening in these tissue types. You know, we could speculate about worst case scenarios and less worst case scenarios, but I think it's problematic. And, you know, I think it's basically, we will look back in this period and say, what the hell were we thinking? That's what we'll look back. And probably the only company that's going to come unscathed through all this sort of thing is funny. It's going to be Sinovac and Novavax that have used a more traditional approach and less problematic approach. No viral vector or mRNA technology, which is the stuff that's problematic from what we can see. And that's the guy who actually invented the technology. So we're not talking about some crackpot. We're talking an actual researcher that's looked into this area. So anyway, I think I've gone too far, longer than I actually expected to say, but I got on another one of my rants. Anyway, I hope you enjoyed this little rant of mine. I will leave it here. Thank you. See yous.